Saucier, this is a video lesson on the inverse of absolute value. Let's work with an equation that has an absolute value in it. This is y is equal to 2 times the absolute value of x plus 1. These are the absolute value bars. We could also call them magnitude of x plus 1. Before we get started, let's get an idea of what a function like this looks like. This is the absolute value of x that has been moved left by 1 and vertically dilated by 2. It looks like this. And before we take the inverse of this function, let's remind ourselves how to deal with the absolute value bars in a solution process. So if we choose a value for y, then we're going to remind ourselves how to deal with this equation. We're going to solve for x. We're not finding the inverse. We're simply solving. I chose a value for y, so x is the only variable represented in this equation. How do we get x by itself? Well, we're going to undo multiplying by 2 by dividing. Dividing both sides by 2 gets 2 is equal to the absolute value of x plus 1. How do I undo the absolute value bars? From a previous lesson, we were shown that when you use absolute value or magnitude, then you're taking what could be positive or negative and you're making it positive. So undoing this conceptually means that if we have what's inside the absolute value bars being positive, then undoing it would then account for both the plus and minus version. So I am going to put the plus minus symbol on the other side. That is the inverse of taking the absolute value. Now I can get two solutions for x, because on the left, I have to consider that I'm working with the positive sign of 2 and the negative sign of 2. I've separated out my two possibilities on the left with a comma, so when I take the final step and subtract 1 from both sides, it'll get x by itself on the right, but I have to subtract 1 from both of these possible solutions. And I get 1 and negative 3. On the graph of this equation, these answers for x, 1 and negative 3, correspond to the two places where y is 4. So this process reminded us that to undo the absolute value bars, we have to add back the possibility of the plus and minus version with this symbol here. But what about finding the inverse? Back to the equation where we have two variables, y is equal to 2 times the absolute value of x plus 1. And if we think on the graph for a moment to get an idea of what the process should give us, we could be reminded that the inverse of a function on a graph is the reflection of the function over the equation y equals x. That perfectly oblique line. If we can visualize reflecting this function across the line y equals x, it's going to look like this. If we called this the f function, then this is what the inverse is going to look like. But how do we use the process of finding an inverse to confirm that? Well, the process of finding an inverse starts with swapping x and y. So where I have a y, I write an x, and where I have an x, I write a y. And then I'm going to solve for my new y. Like before, I'm going to divide both sides by 2. Then I'm going to undo the absolute value bars by including both the plus and minus version of the other side, which cancels out the absolute value bars. And then I'm going to subtract 1. I have two answers here. I'm going to keep the symbol plus and minus x over 2 minus 1 is equal to y. And then I'm going to show both versions as equations solve for y, now putting y on the left. Y is going to be equal to x over 2, or 1/2 x minus 1, and y is also equal to minus x over 2, or minus 1/2 x minus 1. And both of these together are the solutions, or the inverses, of my original equation. If we take a look at both of these, they're lines. Both of these equations are linear. One has a half slope, the other has a negative half slope, and a y-intercept of -1. That means that this graph here, if I was to graph these equations that came through this process, would be the entire line with a half slope, and also the entire line with a negative half slope. But my graph of the inverse should only be this V that's open to the right, not two entire lines. So where in the process can I deal with this? We have to add to the process a part at this step where we have solved for everything but what's in the absolute value bars. We have to include now the understanding that x divided by 2, what's on the left equal to an absolute value, has got to be greater than 0. At this step here, what's on the left cannot be negative. It could be equal to 0, but it can't be negative. It has to be positive because it's equal to the absolute value of something inside. Now that we made that observation has to follow through and carry as part of the solution process all the way to the end. But I'm also going to solve it for x. X divided by 2, I can get x by itself by multiplying both sides by 2, and when I do, x will be equal to, greater than or equal to, 0 times 2, which is still 0. And this step carries through every line of work until I get my result, which are the two equations, but also only when x is greater than or equal to 0, which means that this inequality that started here becomes a domain restriction if I was to finally graph these. And in graphing these two lines with this domain restriction, it means that I'm only considering positive x values, which means I don't get the portion of the line that is less than when x is less than 0, and that then produces the inverse that I expected. Let's provide another example of this solution process. We have an equation y is equal to the absolute value of 3x minus 4, and then plus 1. I'm going to find the inverse of this equation. First step is switch x and y. X is equal to the absolute value of 3y minus 4, then plus 1. I need to solve for y. I'm going to first subtract 1 from both sides. It's at this step where I have something that is equal to the absolute value of something else, and I put a comma because it must be recognized that x minus 1, whatever's on the left, has to be greater than or equal to 0, because that's what it means to be equal to an absolute value of something. Now I have two things to keep track of for the remainder of the solution process. I'm going to undo the absolute value bars with a plus and minus. I'm going to put the x minus 1 in parentheses now because it's plus and minus all of the left side. And in this inequality, I'm going to solve for x by adding 1 to both sides. Now that it's solved for x, I don't need to do anything more to this other than just include it in the process. Once I get x by itself, then this domain restriction is finished. But I'm going to continue to solve for y, which means that I need to add 4 and then divide by 3. And I can show the final answer as 2 equations. Y is equal to 1/3 for plus x minus 1, and y is equal to 1/3 for minus x plus 1. Both together with the domain restriction that x has to be greater than or equal to 1.